I was on mute, sorry. Hey everyone, welcome back to the another live and yet another event of CNCF Nashik. In today's session, we have amazing speaker with us, Marino. Hey Marino,
Hey everyone, how's it going? Hey Kaiwalya, how are you doing?
great. So in today's session, we will be seeing what are microservices. We learn a lot about microservices and we hear them about in day to day while we are working with Kubernetes maybe or DevOps. Whenever we try to get into this field, we always hear there are microservices, service discoveries, and all these terminologies. And today, Marino is here with us, who is going to uh, talk about what are microservices and maybe get us through a demo of working application and let's see how that goes. So Marino, would you like to give yourself a quick introduction and then we can get started?
Yeah, certainly. So hey everyone, my name is Marino Wijay. I am a platform advocate at Solo, but I also live up in Toronto, Canada. So I'm pretty much the other side of the world here because I think that you're basically hosting this out of India, right, Nashik? So this is like really exciting. Kaiwalya, thank you so much for like having me here to be able to just talk about microservices and whatnot. I mean, there's so many different things that we can talk about in this space, but I had to really think like how can I narrow this down, be very specific, and just not ramble on. So yeah, thank you for introducing me.
Yep, that's actually really nice because yeah, the chapter is pretty much new. We just started it off in like December to the end, so it's pretty new, and we are trying to build this CNCF and DevOps ecosystem here. So it's really great. The like audience is new, and even if the platform is uh, like online, we run virtual meetups as of now. So it's really great to make it for beginners and try to make introductory sessions with hands-on as much as possible. So thank you so much for joining us. And you would, if you would like, you can just share your screen for presentation. Let me know.
Yeah,
And
let me go ahead and pick my window here. So that should show up very shortly. Perfect. All right. Well, again, let me introduce myself and introduce the topic. We're going to talk about microservices. Now, there's a bit of a perspective and lens that I'm coming from that I'm offering up, and it really comes down to this idea that microservices are plentiful. There's so many out there, and we have to think about how we connect to them, how we secure them, how we see what's going on with them. So let me paint a little picture for you as we go along, and you'll see how it becomes very complex. And then we'll hop into a bit of a demo environment so you have an idea of what's going on in the world of microservices today. And with that, I already introduced myself, so no need to do that again. But if you'd like to, feel free to follow me on Twitter. And at the same time, feel free to check out some of my blogs, connect with me on LinkedIn. I actually will share something at the very end of the presentation, just so that y'all can see some of the public work that I'm doing as well. Um, but how did we get here? How did we arrive at microservices? So to understand a microservice, it really comes down to this idea of how did we achieve this level of agility with something that is so tiny? It really comes down to this fact of, we have all of these small little moving pieces of our application, which is what I'd refer to as a microservice. But what has changed over the past 10, 15, 20 years is that we've been able to pack more of these microservices onto servers, meaning I have more CPU, more memory, and more storage space, and even access to the network, like a lot more access. I have a lot more bandwidth. But not only that, over those 2 decades, we saw the rise of automation, the rise of release management using principles of CI/CD or continuous integration and deployment. And then you saw this movement of DevOps where you have these practices that are put in place to be able to allow individuals to release quickly, but also support those releases, support those applications that are running out in production. And then you have these tools, these elements, these frameworks, these languages, and even mechanisms that you can work with to be able to deploy your microservices and leverage DevOps practices. So you'll see things like YAML show up, which is a markup language, how you basically define how your microservices look in the environment that they run in. And then there's also this element of where, which is cloud. One of the things that we've seen over the last 5 to 10 years is the rise of cloud. What that means is, versus having to go procure your own server, install it into your data center, set it up and online, make it available on the network, and then start loading applications into it, is one of those particular situations that we see less and less of now, because it's so easy to just go to a cloud provider like Civo Cloud and procure a cloud instance, a cloud virtual machine even. But what do we do with that virtual machine? We can automate it. We can do things with it. We can write some sort of layers on top of it so that we can run these microservices. But before we even dig into that, let's differentiate some things here first. One last thing I'll add is that one of the most important aspects that we were driving for was efficiency. So if I have all of these different servers that are providing CPU and memory and disk resources, I want to be able to take advantage of everything, but I want to do so in a very efficient manner. So I need some intelligence somewhere that exists to allow for this. So let's talk about the differentiation between the traditional deployment versus what we see as a microservice today. So traditionally, what I would have done is, I literally buy a server, install the Linux or Windows operating system on top of it, and then proceed to install my application. But one of the challenges with something like that is you've actually wasted a bunch of resources. There are a lot of idle CPU and memory resources or cycles that are just sitting there waiting for someone to use them. And so about 20 years ago, actually that is right on time. About 20 years ago, this movement of virtualization started, where you could actually take multiple instances of operating systems and pack them onto a physical server using a hypervisor layer. That hypervisor layer provided memory and CPU and even disk management to be able to carve out resources for a wrapper, a virtual machine wrapper, which contained an instance of an operating system which you installed your application on top of. But this actually, while it solved the resource problem, it didn't solve the problem of how do I release quickly? Because here's the other challenge. Every time I needed to update my code, that means I might have to update the entire stack altogether. I have multiple pieces in my app. I might have one large block of code that's running in my app, that's running my app effectively, that's on top of this operating system. So, the recompilation of that app and then to redeploy it is very time consuming. So this new artifact arrived. Well, actually, it's been around for a long time, but it started to take the front seat. It started to, be at the forefront of how we deploy things, how we actually create our applications. And that is called a container, where a container doesn't necessarily have an operating system. It just provides the runtime environment for an application to run. But at the same time, I can write smaller bits of code and store it inside of this container alongside its libraries, any sort of binaries that it needs to use, and then do that a few more times, and then still run this on a single operating system. Heck, I could even drop these 3 containers inside of a virtual machine, inside of a hypervisor, inside of an operating system, inside of your physical server. But here's where it gets very interesting. Now, each one of these little artifacts, these container artifacts, they're built somehow. They're built as images, but they're also managed somehow as well. Well, the way you would manage a physical server here on the very far left is you would remote into it, or you'd physically walk up into it, plug in a keyboard, mouse, and monitor, and manage the system. Or if you're using remote system or remote tools, and you'll manage it that way through your local system, and then use those remote tools to access. The same idea would apply to these virtual machines as well. But then when you have so many containers running, when you actually have thousands of containers running, it actually becomes very challenging. Actually, it almost makes no sense to want to manage individual containers anymore. And so this is what you end up with. In fact, if we go back, you could actually say that each one of these containers is a microservice. So a microservice is a small part of your application that provides a single function, a single output that either you as an end user might consume or another microservice might consume so that it can provide an output to you. Now, that being said, you have millions of them all over the place. And one of the biggest challenges with having to manage millions of microservices is that you can't seem to have them all under a single roof. It actually is not very easy to do. And so principles of ephemerability and immutability, or sorry, ephemerality and immutability come into play here, because what you're actually after is the end result and something to run to provide that end result. And a container will do that for you. A container is something so lightweight. And so this is where that world of release and DevOps really come into play here. Microservices are a place to land your code, but we have to do something with those microservices. We have to find a way to manage them. We have to find a way to scale them appropriately and always make them available. So how do we do that? Well, since a container is representative of a microservice, and if we have 1,000 containers, we need some sort of management system to be able to handle that, some sort of orchestration system. Now, there are so many container orchestration systems that probably exist out there, but they might be proprietary, built by companies because they're like, hey, we're using all these containers, let's build some sort of automation system in place. Now, on the other hand here, some companies started to realize that, hey, maybe so many other organizations and end users can take advantage of this. And so something called Kubernetes was born. Now, Kubernetes is probably the most widely used container orchestration system to date. There are others out there that exist, but we're not going to dig into that. I mean, the reason why is because we're here to talk about microservices, and Kubernetes is actually the best backdrop for that. Now, what does Kubernetes offer up? It offers up a wrapper for that particular container. Now, if you remember, right, going back to it, a container is just simply a runtime environment that houses that application code and the necessary binaries and libraries for that code to run and provide a meaningful output. But if we have so many, we need a mechanism to be able to manage that with Kubernetes. And so Kubernetes presents something called a pod as a resource, which is its single unit of compute. You store your container inside of that pod, and that pod then gets managed by Kubernetes or using the Kubernetes orchestration layer. Now, in that pod, you can assign things like storage, you can assign things like a network, you can assign access to a service mesh, meaning you'll deploy something called a sidecar resource. And what that means is now that container has a way to access additional resources, but you don't have to go sit there and program it all the time. You do so through the Kubernetes layer. Now, what happens is I can take all of these different containers, store them in pods, and run multiple pods inside something called a node. Now, that node actually could either be a virtual machine or a physical host. Now, let's just pretend for a second here. If you can look back here and look at those little boxes there, they're NUCs. Now, I'm just going to hold on. Let me pull up the camera here. These NUCs here are representative of physical servers. And those physical servers house these pods. You could actually think of these physical servers as a node inside of Kubernetes. Now, that being said, if you have multiple nodes, like I do in my case, right, I have 3, now I have a distributed infrastructure environment, which effectively provides me the ability to run multiple pods across multiple nodes. So you could pretend that I have like multiple nodes here. In fact, I think the next diagram shows that. Yeah. So I have multiple nodes here, and then I have multiple pods. You don't see the applications, but you can just assume that they exist here. And then I have a control plane where I can drive a lot of this automation, a lot of this orchestration, provide access to um, applications to get on the network and be accessible on the network, whether internally or externally. Now, the thing to consider here, though, is my entry point is not directly to the application if I am managing the infrastructure layer. My entry point is something called the Kubernetes API server, where I will come in, communicate with the API server securely, and issue it commands so that I'm telling it what to do with what particular resource. Because everything here that you see is a resource. In fact, an application, if we go back here, these pods are all resources. And I want to be able to do something, and I'll do something through the Kubernetes API layer. Now, this allows me to easily scale my microservices. It allows me to provide some redundancy and availability for it, because something that Kubernetes does very, very well is maintain something called desired state. If I say to Kubernetes, I want my applications to always look like this, then Kubernetes will always make sure that it looks like this. And the reason why that is because you fed it a manifest, you fed it some details, a set of instructions or a blueprint that it always needs to maintain. And as long as it has access to things like the network, the nodes that it's communicating to, it will maintain that for you at all times. Meaning, if I say I want these containers to be deployed as pods at all times, Kubernetes will maintain that for us. So that being said, the reason I have multiple nodes is to provide availability, to run multiple instances perhaps, so that I can have some mechanism of load sharing across multiple copies of my application. And then there's the networking piece of it. Now, in the world of Kubernetes, there's something called container networking, where all these different containers are on a network and they are able to communicate with each other. They have the ability to. Then you have to think about security. How do you protect these layers? How do you ensure that these different containers that aren't supposed to talk to each other don't? And that's where some level of networking, like a container networking interface, comes into play here. Excuse me. But when you think about a container networking interface and you think about that layer, it can only handle and process so much in the way of traffic movement. We're talking about packets here and what we can do with packets. But we don't always know what's in those packets, and we have to better understand that at a different layer. Now, that different layer might present itself as an API layer. In fact, every little service will present up an API. And what that translates to is, if I have an API, well, okay, I can do things with it. I can issue get commands. I can issue delete commands. I can issue any sort of patch commands to be able to modify a resource or something along those lines. And that is what we do with the Kubernetes API. Now, would you in production ever directly interact with the Kubernetes API at all times? Probably not. And the reason why that is because you're going to be using some sort of CI/CD and automation tooling to be able to push your applications in the form of containers inside of pods to Kubernetes clusters that you'll run inside of your production environment. The only time you might interact with it is if you have issues with the control plane or resources running in, or really applications running inside of your clusters. Then one more thing I'll point out is Kubernetes operates in a distributed control plane and data plane model. The distributed control plane is comprised of multiple different pods doing different things, and that is separated from the data path as well as the data plane. Now, our nodes behave as the data plane because they run our applications and they allow data to move around between nodes and get instructions from the control plane. You'll also normally see in a production environment multiple control planes or multiple control plane instances to support that environment. Now, the ecosystem becomes quite extensive, and that's because you're never just going to run a single container. You're never going to just manage 10 containers on its own. You're probably going to sit there and deal with thousands of containers running in different forms, running with different code bases, running on top of different CPU architectures, running on top of different operating systems. And this becomes very, very challenging. And so you have this ecosystem that exists to be able to handle a lot of these different aspects. Now, the ecosystem really is comprised of where am I going to run this? Meaning if I'm going to do this on premises or if I'm going to do this in the cloud, and then how am I going to run this? Am I going to run this as a virtual machine, as a physical entity inside of a container? Am I going to use Kubernetes to orchestrate it? Am I going to use tools like Prometheus and Grafana to understand how my applications are performing? How am I going to connect all these services? How am I going to provide identity or and trust to all these microservices? These become very problematic as you start to think about running a lot of this in production. And so while I'm not going to be able to cover everything about running things in production, let me point out an area that becomes very interesting when you think about a networking stack. So you have this microservice and you scale it and you have various microservices doing things. You need to run it somewhere. So we either have physical hardware or we have a private cloud or a public cloud, whatever it might be. And then on top of that, we will carve out a virtual network for some of this networking to live. So our microservices have a place to interact. If you've worked with the cloud, then this will be better known as a VPC or a VNet if you use Microsoft Azure. And that's just really carving out a subnet. Now you carve out a subnet because you're creating a network island there that you'll connect to later on. Now, a lot of this will either be x86 or ARM architecture, depending on what you're after. If your code supports ARM, if you're deciding you want to use maybe embedded systems, or maybe you're looking to use a smaller footprint, which ARM does offer up, that's a decision based off of what you're trying to do. And then you'll have something like a runtime environment, a container runtime environment. But once you get past that, then you have the orchestration layer. The orchestration layer can be anything. In my case, or in our case, it's Kubernetes. The orchestration layer is handling all of these different microservices that are running. And while you're providing it instructions, you're still allowing it to provide some orchestration on behalf of you. So you're not having to sit there and manage it. It's just looking for conditions. When conditions changes, it'll act. But then you also need a way to connect it. And so you have this networking layer on top, which is your container networking interface. And then finally, you start to realize that things like observability, things like identity and zero trust, and much more granular traffic routing become very important, especially at the API level or at the gRPC and HTTP layer. And so this is where a service mesh might come into play here. So when you think about building out microservices, you have to think about the stack that's going to be able to support this. And while this is not the complete stack, there's so much more to it. There are other things that come into play here, like how are you going to version control this? And that's why I threw up Git, because Git is an excellent version control system that allows you to manage different aspects of your applications alongside your network. And then most of the time, you're probably going to define this in YAML as well. Now, to really wrap this up, right, you have this microservice. That microservice houses a piece of your application because you have multiple different microservices operating together to give you a larger application stack. We're actually going to see this in an environment very shortly. And then you'll orchestrate it using Kubernetes, connect it using a network interface. These microservices, though, need identity. They need to be able to understand the health. We need to understand the health of them, and we need to be able to intelligently route to them. So before I get into the demo, are there any questions? And I'm going to go look in the chat. Here we go. I see a lot of hellos. Hello, everyone. Thank you for coming by. Yes, you're right. Then Kubernetes comes in play. I've been confusing objects and resources for way too long. And then Raul says, what is service mesh? So service mesh is a layer on top of the CNI layer that provides traffic routing and management, as well as deep metrics and observability, as well as things like encryption and authorization, as well as authentication between your microservices. So before I dig into that, which is the live environment, I'm just going to plug a few things here. Actually, I'll come back and plug them at the very end so that y'all have these resources. So let's switch over to the demo environment quickly. And while I'm doing that, I'm going to get some water here.
I don't know how many people recognized it, but your hat says really cool text. Got mesh.
Exactly, exactly. So yeah, one of the reasons I don't know, I think it was KubeCon NA, and then they were handing out these hats, and I'm like, I want this, and they put it on, and I love it. I love it. All right, so I got my
Yep.
environment ready. If you want to make it live, all right, cool, cool. Okay, so this is a Kubernetes cluster. And no, I don't use aliases because I want everyone to know what that full command looks like. This is a Kubernetes cluster that's actually running on Civo Cloud. I have 3 nodes in the cluster. You don't see the control plane, and that's fine. But I will show you something else. I have these 3 nodes, and actually, this might be a little bit harder to read. But if you see, right, these 3 nodes are housing all these different applications, and you can actually see these are the 3 nodes that we saw up here, and these are the different microservices actually that are running in this cluster. So if you actually look at these pods, they are representative of the microservices that I was referring to. This is a pod here, this is another pod, this is another pod, and then a few more pods down here. They all run containers inside of these wrappers. Now, if you see this column here, it says ready, 2 out of 2. What that's indicating is that there are 2 containers totally running in this pod, because you can actually define multiple containers inside of a pod. They'll share the same networking namespace and the same set of networking resources. But the other thing too is that, why are there 2? Normally when you deploy an application, there should just only be 1. And I can even show you what that might look like. So if I do a kubectl create namespace, and I call this sleep, and if I cd into my istio 1.16 folder, samples, sleep, here we go. Okay. So if I do a kubectl apply -f sleep.yaml-n sleep, what I'm effectively doing is now I'm going to deploy the same microservice that I have up here, but into a different namespace. I'm not going to get into the idea of namespaces and whatnot, because it's a very deep concept, but the simple idea is it's a mechanism to provide some sort of boundary from an application standpoint, but it doesn't truly limit interactions or connections between applications. What that just simply means is if I have resources grouped into this namespace, it's serving up a particular purpose. So from a logical standpoint, I know it's in its own little operating environment. What I can do with that is I can actually assign resources and quotas to those resources so that I never overexceed the amount of CPU and memory in that namespace, so that I don't consume everything available inside of my my host. So the moment I deploy this, right, if I do a kubectl get pods, I'm just basically issuing a command to the Kubernetes API to say, hey, tell me about the pods in the sleep namespace. The -n means dash namespace. you can see that I have a sleep pod running and it only has 1 out of 1. Now, I'm not going to get into the deep details behind this, but the difference between the two is that this doesn't have a sidecar, but this does have a sidecar, which means that this application right here is part of the mesh. Now, if you recall the diagram I showed you earlier, that diagram actually was representative of the fact that, and I'm talking about the network diagram where you have that network stack, that it was representative of the fact that I have all of these containers and microservices running. I need a layer on top. Right now, seeing the 2 out of 2 means that I have my layer that's running on top, and I can actually access my application in a number of different ways. So if I wanted to access that particular application, I could do so this way. So I'm going to type in kubectl exec pod sleep. Sorry, I have the command somewhere up here. I can't even remember the full command. I think it's curl, and then I have to provide the actual page 9080. That should work. Oh yeah, I took the did I take the right sleep? Oh no, there we go. There we go. All right. So what just happened here is that I remoted into one container. By the way, the sleep container automatically puts when I remote in, I usually would specify the specific containers because there are 2 containers, but it automatically knows that I'm trying to get to the main sleep container and issue a command from it. That command I'm issuing is curl the product page. So from a DNS standpoint, product page resolves to product page.default.svc.local for a DNS name. So Sleep automatically knows the DNS name for product page. So as long as I specify this along with its port number, what ends up happening is when I curl it, you actually see, it provides a response. Hello, this is a simple bookstore application consisting of 3 services as shown below. Those 3 services are actually right here. So when I connect into product page is a microservice that communicates with the details the details service, reviews v1, and the rating service, and even reviews v2 actually. You see a reviews v3 because you can't actually canary release it, which I'm not going to talk about today or dig into. But the idea is that let's just say I have version 1 running, and then I decide I want to route request to version 2, and then I decide I make a change and I want to route request to version 3. How do I handle that? Like, I have to find a way to network that, right? And this is why a service mesh comes into play here, because a service mesh allows you to then route to whatever resource that you're trying to get to and even lock down those routing rules. You can say that, hey, product page can only talk to the reviews and the details service, but the reviews service, any one of these 3 can talk to the rating service, but that's about it. So that way you lock that down, and so you provide yourself a zero trust approach. Now, in our case, because we have the sidecar running, there are 2 ways to access this application. I can access this externally from the egress side, or I can, if I'm trying to access this from the ingress side, or sorry, what I mean to say is I can access this coming like inbound from my host, from my local host, into this application, or I can do so from within the environment itself, like you just saw. So the way to do that, give me a second here. I'm just going to grab something. So how do I want to do this? I'm just trying to see if I should do this through, actually, yeah, this works perfectly. Okay. I actually will need to set up a quick local host file so that I don't expose my public IP because I don't want to get hammered on potential changes. But what I'm simply trying to do is I'm creating a local DNS record. And that local DNS record just points to a host name that I can edit and create a local DNS entry. That's really it. So while I'm doing that, Kaiwalya, do you have any questions that you'd like me to answer?
Yep, actually, we have a question from Siddhant. He's saying that I have seen folks talk about sidecars and sidecarless service mesh. So, what are those?
So sidecar and sidecarless. So there are two modes of operation right now. The first mode of operation is the sidecar approach. That sidecar approach simply implies that you're basically deploying the sidecars that you see up here, right? 2 out of 2. And that means that the sidecar acts as a proxy. It acts as a proxy to be able to facilitate communications on behalf of the container. So there are 2 containers. One is a sidecar. That sidecar is acting like a router and a proxy, while the other is actually behaving like um, the application container. The sidecar proxy routes all those requests. But in the mode of sidecarless, the sidecar function actually moves outside of the pod and lives as a node level proxy, known as, and in the world of Istio, that's ambient mesh, it's known as the Z tunnel. So that's really
Hmm.
the gist of it, but there's a lot more to what that really means. Sorry, I'm almost here. Um, Adding in my
Yep. So there is no case like this is better than that. This base, like this depends on the kind of application and service mesh you are trying to build, right? So even if, let's say, suppose I am in like a environment where I need sidecars to be there, then I will go with it. If I want like different approach, then I will go with sidecarless. So it's not like based on this is best than this or this is best practice, something like that.
That's correct. So the thing to consider, right, is that it's all entirely dependent on the particular workload that you're trying to handle in terms of its connections, understanding its application resiliency, understanding whether or not it's behaving the way you expect it to, whether or not you can provide high availability. Now, on the other hand, there are applications that actually don't see any benefit to using the sidecar. In fact, they don't offer up the same level of communication streams to be able to better understand what the application is doing. And this might just be because the application only operates at TCP at the
Mhm.
when you look at the OSI model. So a sidecar doesn't really benefit certain resources. In fact, it might even complicate certain things as well. Now, one thing to consider is that you're always going to have to think about your design requirements, your application requirements, and that's going to dictate whether or not you take the sidecar approach or the sidecarless approach. But it's never going to be either or; it's going to be and. Okay.
Okay. Yeah.
All right. So let me go ahead and share one last screen here, and then you can see something. Oh, can I do multiple? No, I can only do one. All right. So if you can see my screen at the moment, this is the application that is running basically the 3 different microservices, or sorry, the multiple different microservices. But every time I hit refresh, right, I want you to pay attention to something. See, right now with the red stars, it's calling on reviews v3, which is telling us, hey, give us the ratings, but in this color. So if I hit refresh again, right? I'm still going to reviews v3, but I hit it again. Now I'm going to reviews v2, which is telling the rating service to present this in the black stars. So if I hit refresh again, I get v3, refresh. And now if I go refresh again, I get V1. Now this is the name of the pod. If you recall, if we go back to our diagram, which actually, or sorry, our console, you'll see the name of the pod that shows up. Now, also look at the browser product page. I'm going to the product page microservice. The product page microservice is communicating with the reviews and the details. The details is what shows up here, the book details, and then the review service presents what we see here, as well as what the rating service will give us. So let's go back to our actual application, our console. Sorry for the bounciness here, but I just wanted to point that out. So if I go run a kubectl get pods, or in other words, show me my microservices, look, this is the product page that I connected into, and it's communicating with either reviews V1, which is up here, V2, or V3, and each one of these microservices are communicating with the rating service. So all of this is there, right? What I just showed you was the result, the output of that application. Now, the one thing I didn't show you is my public IP, and the reason why is because, like I mentioned before, I want to make sure that it's protected because I don't want to have to recreate the environment. I probably could, but I'm going to use this environment for something else anyways. You're actually not using, I'm not using the load balancer service directly to expose any of these IPs. Let me show you something. Because I'm in the default namespace, I can show you this. How did I access product page if I'm using the cluster IP service? So it's because I'm using a sidecar. The sidecar is now routing that request back to something called an Istio ingress gateway. If I actually do a kubectl get pods -n Istio system, this Istio ingress gateway is my entry point. You can think of it as the router to get into my service mesh or into my Kubernetes cluster running these different microservices. Once I am in, this router here will say route to this product page router, and then that product page will then route to the routers or the sidecars, I should really say, to any one of these review services. So there's a lot of routing going on, right? So that's what's really going on here. But I come in through this ingress gateway, and then I go to my product page, and then my product page will get results from all the other services there. But the one thing is, I'm not using a load balancer service for any of these services. In fact, the load balancer service is tied to this, and that's why I didn't want to show you it, because my IP will actually show. But in any case, that's how I can go about accessing my application. I can actually manipulate this to make this a lot more extensible and expose all these others, which I wouldn't want to do because no one needs to access the review service directly. They need to access the product page, which will then sequentially access these other services in line of the request. So these are microservices. This is how they operate. They interact with each other. They have instructions to communicate with other pieces in the network to form that major application. In fact, that website, if we will go back to it one last time, that website, let me pull it up. Here we go. Right here is comprised of all those microservices. So like I said, this one massive web page is the product page microservice. The book details is the details microservice. The reviews microservices, one of them will show up every time you hit the refresh screen, and then we'll contact the rating service, which will provide a rating in either no format or star format. So that's, when you think about it, this is how microservices work. When you look at a website like Kubernetes.io, I'm sure it's comprised of many different microservices as a website. Now, one last thing, right? When it comes to microservices as well, Kubernetes, again, isn't the only place to be able to deploy these. If you want to test this out, you might, have a local laptop or a desktop, and you can run Docker. And you could actually deploy something called a Hello World container. There's even a quick tutorial on how to do it. When you deploy that with something like Docker, you basically now have a microservice running on your computer. So give that a shot if you want to. Now, just to kind of wrap up, I just want to provide a few plugs for anyone that already has a good understanding of Kubernetes, and wants to take the next step, understands Kubernetes networking, has played with API gateways and ingress networking, follow along with 70 days of service mesh. I decided to do this because of one of my good friends, Michael Cade. He actually went ahead and created something called 90 days of DevOps. And as a result, I'm like, he asked me, can you create a 7 days of service mesh for my 2023 iteration of 90 days of DevOps? I'm like, sure. And then I thought to myself, let's take that and expand upon it. So I decided to create 70 days of service mesh. So go check that repo out. You can even quickly search the hashtag and you'll find links to the repo. Feel free to follow along by forking it, starring the repo. I hopefully will be able to get out day 3 today because it's not a heavy tutorial. It's something very straightforward, informational, comparing different service meshes out there. Also, this is the first time I'm talking about this publicly. Well, I kind of tweeted about it, but I am running a conference in Toronto called KubeHuddle. It is an extension, actually, the next iteration of KubeHuddle that happened last October in Edinburgh, Scotland. A lot of amazing technologists, developer advocates, engineers came together to a community conference and we presented. So if y'all are interested in attending, tickets will be available soon. If you're interested in submitting a talk, the CFP system will be open as well very shortly. But head over to the website so you can get a sense of what's going on. And we'll definitely be in touch and we'll be updating more and more of it. The very last thing I have for you is if you're looking to dig into more, there are resources that I have left behind. You can easily Google all of this, and all of the information should be very readily available. Solo Academy. Head over there if you want a very stepped approach to understanding networking for microservices, from basics to hey, let's do multi-cluster networking with microservices, to let's run CEVO cloud. If you want to get deeper into Kubernetes, there's Anai's 100 Days of Kubernetes. Kunal has an amazing set of tutorials for Kubernetes as well. Check out his channel. And then if you actually want to follow Michael Cade's 90 Days of DevOps, another great place to go. So that being said, I just want to say thank you so much, everyone, for coming by and learning about microservices. I shared maybe 0.01% of microservices and what they are today, and how to work with them and how to interact with them. But there's so much more, right? I highly suggest y'all go hit up these resources, follow Kaiwalya, because Kaiwalya has been amazing in the community, sharing resources, connecting folks together. Follow the folks on Twitter that actually talk about microservices, talk about Kubernetes and DevOps and whatnot, and you'll learn so much more. Even follow me too if you want to, and I can provide some guidance for y'all as well. Back to you, Kaiwalya.
Yeah, thank you so much. Actually, this was very informative session, as I am also like poking here and there into CNCF ecosystem, trying to learn new things and trying to tweet about it and create more content about it. And I'm trying out YouTube videos as well, so live like this, and then recording some videos, making concepts more simpler to people. So yeah, yeah, here anyone if they are new, you can check out my channel as well. And Marino is here. Marino is also creating content, and again he is having a conference, so CFP will be open as Marino said. So keep an eye on it. Even if you are not sure, submit a CFP. I'm sure Marino will be happy enough to review all the CFPs, right? So, yeah, thank you so much for joining us, everyone, and hope you learned it. Please do share all your learnings in public, and whatever you learn, anything, any single line or any concept you learned, as because I learned sidecast today and difference between them. So I will be tweeting about it. You also do the same. And yeah, check out all the socials of Marino. It will be in description in short. Check out CNCF Nashik chapter. Many amazing opportunities and sessions will be coming up. And yeah, see you soon. Bye everyone.